Hello, good afternoon. Can you hear me? Hello? Okay, Anurag. Okay. So I'll share my screen now. Please tell others to join fast. Can you see the screen? Okay, okay, okay. So only 11 have joined. I'll wait for one more minute. Please tell others to join. See, why only very few are here? So anyway, I'm going to start. Okay, so in the morning, do you remember what we were discussing? Do you remember what we were discussing in the morning? How many properties did we complete in the morning? We were discussing about the properties of relations, and which all properties did we complete so far? Can you name those properties? And based on those properties, those relations can be classified into those types. Okay, so what are those properties? And those relations that satisfy those properties, say we call that relation by that name. So what are the properties? Quickly, can someone say? Okay, and reflexive. First was reflexive, Vagarsh. Okay. Then second, symmetric. Very good, Google. Reflexive, symmetric property. Then anti-symmetric. Very good, Nivedita. Then last one. Okay, Agarsh, anti-symmetric. And then last one. Okay, Isha, transitive property. So we were discussing about transitive property, isn't it? The last one. And what is transitive property? See, I said if in a relation R, okay, if in a relation R, suppose a relation R has the ordered pairs AB and BC, then what should also be there for it to be transitive? The relation R has AB and BC. Then, if these two ordered pairs are present, then the third ordered pair, that is AC, should also be present. Only then this R will be considered as a transitive relation. That is, it will satisfy the transitive property, and such a relation that satisfies the transitive property is called a transitive relation. So if AB and BC is there, then AC should be there. If AC is not there, then this is not a transitive relation. Okay, if AB and BC is there, then AC should exist. Otherwise, this relation, if AC does not exist, then it is not a transitive relation. That is, in relational form, we can write if A is related to B and B is related to C, then A is related to C. And if such a relation exists, only then we can call it as a transitive relation. Okay, now let us look on example. I think we had discussed one example here. That is in relation R. I'll write it once more. If R, relation R is equal to 1, 2, 2, 4, 1, 4, then 1, 6. Okay, this is some particular relation. You just need to check if 1, 2 is there. You have seen the first ordered pair 1, 2 is there. Next, again, another pair 2, 4 is also there. So if two such ordered pairs are there, then you have to check if 1, 4 is there. Again, 1, 4 is also there. So this property is satisfied. So here we are not bothered about the other ordered pairs, because in only 1, 6 is there. Suppose another element 6, 3 was there here, then again you should look 1, 6, 6, 3. Next you should look if 1, 3 is there. If 1, 3 is there, it is reflexive. If it is not there, then R is not reflexive. So if if the pairs of this form, 1 to A related to B and B related to C, if these two ordered pairs are there, then the third should be there. Otherwise, we are not bothered about the other pairs. If these ordered pairs are present, then the third one, that is A related to C, should be present. Okay, and that is transitive relation. Is it clear? Is it clear? Any doubt? Any doubt? Okay. So, now let us look on example. See. Otherwise, I'll give it as an homework. Okay. So when we look at the definition, if a relation R, this is the formal definition. Okay. If a relation R on a set A, you are going to define R on a set A, it is called transitive if whenever AB is an element of R and BC is an element of R, then AC is also an element of R for all ABC which are elements in set A. So this is the formal definition. That is, if AB is an element of R and BC is an element of R, then AC is also an element of R. So that is the definition of transitive relation. Now let us move on to some examples. See, is divides relation on a set of positive integers transitive? We are asked to check whether the divides relation on a set of positive integers is transitive or not. The divides relation. With examples, it is easy to prove that the divides relation is transitive. Okay. So the question was, is divides relation? Write the question. Okay. After writing the transitive property, you can write the question. Is divides relation on a set of positive integers transitive? Is divides relation on a set of integers transitive? That is, let us take a few examples. That is, or I'll put values here. So 2 divides 4, okay. Then 4 divides 8. Then 2 divides 8, isn't it? So division, we are concerned with the division relationship. So if A divides B and B divides C, then A divides C. So these ordered pairs, if it satisfies transitive property, then these three ordered pairs will be present in that relation. Okay, so we can generalize this. No, with examples, we can prove only 2, 4, and 8. So we have to generalize it for all positive integers. To generalize it for all positive integers, let us see what we are going to do. Okay, see, the generalized definition is given here. That is, suppose that A divides B. Suppose A divides B and B divides C. Then we can see that there are positive integers k and l. If A divides B, then B is equal to some multiple of A, isn't it? A into some multiple k. If it exactly divides, then B is equal to a multiple of A. And C divides B, then if B divides C, then C is equal to a multiple of B, isn't it? If division is if it is exactly divisible, then B is a multiple of C. So if you multiply B by a positive integer L, you will get C. And also if you multiply A by a positive integer K, you will get B. So this is the division property. That is, if A divides B, then B is equal to a multiple of A. That is mathematical properties, isn't it? Likewise, if B divides C, then C is equal to a multiple of B. And now here, in this for this B, we are going to substitute AK. Since B is equal to AK, here I am going to substitute AK. So it becomes AKL, and taking KL together, C becomes a multiple of A into KL. So if we divide this by A and A will cancel. So C is a multiple of A. So this is what the generalized explanation means. So that is, if just look at this example. If A divides B, okay. A divides B means, that is, if A is 2 and B is 8, then you can write 2 is equal to 4 into, sorry, 8 is equal to 4 into 2, isn't it? So that's what we wrote earlier. If this is A and this is B, then B is equal to A into some positive integer k. So here A is 2 and this positive integer is k, isn't it? So A divides B, then B divides C, and B, that is 8 divides, say, 16. Then 16 is equal to 2 into 8. So here this L is 2 and 8 is B and 16 is C. That is, C is equal to B into L. So instead of B, I am going to substitute. Here B, we substitute as AK. So L into AK, or we can write as A into LK. It's a multiplication property. So C is equal to A into LK, and which means if you divide it by A, these two A will be cancelling, and so C is a multiple of A, or A divides C. Okay, A exactly divides C. So that is what we are representing it in statements also here. When you work out this, you will be able to understand what I meant by this. So if B is equal to AK and C is equal to BL, substituting for B as AK, you will get C as a multiple of A. If it is a multiple of A, then C it is exactly divisible by A. So thus we can say in generalized form, we can say that the divides relation on a set of positive integers is transitive. With this question we discussed earlier how many relations are possible. Now let us move on to the different types of relations. There are some types which we come across frequently. One is the empty relation. An empty relation is a set which does not have any ordered pairs, so empty set. Then full relation on a set A is the set A cross A. The whole, if all the elements of A cross A is in a particular relation, then that relation is called a full relation. If all elements of the cross product is there, we said that relations are formed on cross products, and it can be subsets of the cross product, and subset of a relation can be of a set can be the set itself. So if that entire set cross product, the entire elements in the cross product is there in a relation, then that particular relation is called a full relation. Then identity relation on a set A is the set AA. That is, if each element is related to itself, then we call it as identity relation for all A element of A. And that is, it also satisfies the reflexive property. And now we said what is reflexive relation earlier. Then next we are going on to another important section, and that is equivalence relation. This is one section of this topic. Equivalence relation, most frequently asked question for university. You'll be given a set and you'll be asked to prove whether it is an equivalence relation. So we are going on to the next category of relation. Write the heading equivalence relation. So after studying the properties of relations, we had studied four basic properties, and based on these properties we can classify relations. Okay, based on the properties we can classify relations. Is it clear? We had studied four properties, and based on these properties again we can classify relations. So, and mainly we come across two kinds of relations based on these properties. One is the equivalence relation, and second is the partial order relation. So we have to study these two relations in detail. Sure questions for university exam. Most of the questions are concentrated in these two sections. So based on properties of relations, how many properties did we study? How many properties? Based on properties of relations, we can classify relations as equivalence relation and partial order relations. Okay. So we had studied four properties. Based on these four properties, we can classify relations as either equivalence relation or partial order relation. Now let us see how are we going to classify based on these properties. Okay. So first, equivalence relation. What is an equivalence relation? So, a relation which is reflexive, symmetric, and transitive. So, we had studied four properties, out of which one is missing here? Which is the property that is missing here? We had studied four properties, out of which I had stated three properties here, isn't it? Which is the missing property in this definition? Which one is missing in that definition? Antisymmetric. Very good. Antisymmetric is missing. We had studied four properties: reflexive, symmetric, antisymmetric, and transitive. So out of which I'm telling that I have avoided antisymmetric property, and I'm saying a relation R which is reflexive, symmetric, and transitive. If a relation satisfies all these three properties, then we call it as an equivalence relation. Suppose a relation R satisfies reflexive, symmetric, and transitive property, then such a relation is called an equivalence relation. So write it down. A relation which satisfies reflexive, symmetric, and transitive property is called an equivalence relation. Did you write? Did you write? So now let us move. Let us check then what is partial order relation. Partial order relation. I will go to the next slide. Okay, the second type which I told was partial order relation. Second was partial order relation. Now, what is partial order relation? A relation which is reflexive, then anti-symmetric. We left it out before, isn't it? Anti-symmetric and transitive. And transitive is called a partial order relation. Okay, so did you see the difference? It's called a partial order relation. So write it down, write the definitions. Okay, so what is a partial order relation? A relation which is reflexive, anti-symmetric, and transitive is called a partial order relation. So we had studied two relations based on these properties. We are classifying the relations. So what were the two relations based on properties? Based on properties, what are the two types of relations that we can form? What are the two types? First one, okay, equivalence relation. Then next is, what is the next type? Equivalence relation and partial order. Very good. Now, what is the difference between these two? What is equivalence relation and what is partial order relation? What is the difference between these two? What is equivalence relation and what is partial order relation? Anyway, we have to study both the relations in detail. We have to work out examples in detail for both equivalence and partial order relations. First, we will consider equivalence relation, then we will go to partial order relations. So, what is the difference between these two? A relation which is, what are the properties satisfied by equivalence relation? If a single relation R, if it satisfies all the three properties, what are the three properties? What are the three properties? Anyone? You are not listening? What were the three properties? It's so simple. Okay, Akash. Reflexive, symmetric, and transitive. We had studied four properties for relations: symmetric, reflexive, symmetric, anti-symmetric, and transitive. Out of which, if a particular relation satisfies reflexive, symmetric, and transitive property, if all three properties are satisfied by a single relation, then that particular relation is called an equivalence relation. Likewise, we have another kind of relation also, that is partial order relation. And what is the which all properties are satisfied by partial order relations? Which are the properties satisfied by partial order relations? What are the properties? Okay, Ashwin, reflexive, anti-symmetric, and transitive. Very good. So then we call it as partial order relation. So hope you understood the difference between two types of relation. What is equivalence relation and what is partial order relation. The properties of this relation differs. That is, one will satisfy reflexive, symmetric, and transitive. Other will partial order relation will satisfy reflexive, anti-symmetric, and transitive property. Now let us look at an example of equivalence relation. Let us move on to the first type, that is equivalence relation. equivalence relation. So, now write down. Let A is equal to 1, 2, 3, 4, and a relation R defined on A is 1, 1, 1, 2, 2, 1, 2, 2, 3, 4, 4, 3, 3, 3, and 4, 4. So this is a relation that is defined on set A. That is, on set A means these ordered pairs are taken from A cross A. Okay, they are subset of A cross A that satisfies some property, and that those that satisfy the properties are put under the relation R. And I have got all these ordered pairs satisfying a particular relation. Now I want to check if this particular relation is an equivalence relation. Check if it is an equivalence relation. How will you check? So let A is equal to this, R is equal to, did you write it down? Be a relation, question, be a relation on A. Verify that R is an equivalence relation. Verify that R is an equivalence relation. Verify that R is an equivalence relation. Now, how will you verify that R is an equivalence relation? What should you prove? To prove that it is an equivalence relation, what you should do? What should you do? You have to check whether it is reflexive first, then you have to check if it is symmetric, and next, third, you have to check whether it is transitive. We had studied properties of reflexive, symmetric, and transitive relations. So, first let us check if it is reflexive. Is this relation reflexive? Can anyone say whether if it is reflexive or not? Is it reflexive? Only if it is reflexive, then I need to proceed to other type, because if any one is not satisfied, then it is not an equivalence relation. Okay. If it is an equivalence relation, for it to be an equivalence relation, it should satisfy all the three properties. If any one property is not satisfied, then it is not an equivalence relation. So first, let us see if it satisfies the first property, that is reflexive property. Can you say is it reflexive? Anyone? What is reflexive property? What is reflexive property? For all A, which is an element of the set A, AA should be an element of R. I'm just writing it in simple notations here. For all A, which is an element of A, AA is an element of R. Just check if this is satisfied. Just check if it is satisfied. That is reflexive property. So if it is an equivalence relation, it should satisfy three properties. So our first property is reflexive property. Just check if it is satisfied. You can do it first, right? First property, reflexive. Can you do it first? Is it reflexive? I didn't get any answers yet. Akshara, okay, it is reflexive. Why do you say it is reflexive? Why do you say it is reflexive? Akshara? To check if it is reflexive, just take the set A. First element is 1. Check if 1, 1 is there. Yes, it is there. Then next element is 2. Check if 2, 2 is there in this set R. Yes, 2, 2 is there. Then next third element is 3. Check if 3, 3 is there. Yes, 3, 3 is also there. Then the last element is 4. If 4, 4, 4 is there, then we can say that it is a reflexive relation. That every element in A is related to itself. Every element in A is related to itself, then it is a reflexive relation. Okay. If any one of the element was left out, suppose 4, 4 was not there, then it is not reflexive. Every element in A should be related to itself. Okay, then we can say that it is a reflexive relation. That is, in this relation, if every element of A is related to itself, that is A or A all A for all A element of set A, then we can say that if A is related to A for each and every element in A, then we say that a relation is a reflexive relation. Did you understand what reflexive relation is? Did you understand how to check whether it is reflexive or not? Hello? Reflexive check ചെയ്യാൻ മനസ്സിലായോ? ഓക്കെ ആ സെറ്റ് എ എടുക്കുക എ എന്ന് പറയുന്ന സെറ്റിലെ ഓരോ എലിമെന്റും ഇഫ് ഇറ്റ് ഇസ് റിലേറ്റഡ് ടു ഇറ്റ് സെൽഫ് ദെൻ it is reflect that all elements should be present. That is, for all elements in A should be an element of R. So just check ഓരോ എലിമെന്റ് എടുക്കുക 1 എടുക്കുക 1 1 ഉണ്ട് 2 എടുക്കുക 2 2 ഇതിനകത്ത് വരുന്നുണ്ട് 3 എടുക്കുക 3 3 ഉണ്ടോ എന്ന് നോക്കുക ഇറ്റ് ഇസ് ദെയർ 4 എടുക്കുക 4 4 ഉണ്ട് എല്ലാ എലിമെന്റ്സും അതേ എലിമെന്റ്സ് ആയിട്ട് റിലേറ്റഡ് ആണ് എല്ലാം പ്രസന്റ് ആണ് സോ ഇറ്റ് ഇസ് റിഫ്ലെക്സീവ്. Then second, symmetric. What is symmetric property? Symmetric ആണെങ്കിൽ എന്തായിരിക്കും? Check if it is symmetric. Is it symmetric? What is symmetric property? What is symmetric property? What is symmetric property? And symmetric property says that if AB exists, then BA should exist. This is symmetric property. If AB exists, then BA should exist. Now look at the relation. If 1 1 exists, then BA is also 1 1. So this is satisfied. So next, if 1 2 exists, then 2 1 should also exist. So if 1 2 is there, then 2 1 is also there. Okay. If 2 1 is there, 1 2 is there. So this is satisfied. Then if 2 2 is there, again, since both they are equal, this is also present. Then if 3 4 is there, then 4 3 should be there. Again, it is also there. 3 3 is there. Okay. If the elements are same, then it is there. 4 4 is also there. So everything is satisfied. For all ordered pairs, it is satisfied. Then we say it is symmetric. Okay, check if AB is there, then BA should be there. 1 1 is there, so 1 1, since we needn't write it twice, it is there. So 1 2 is there, then 2 1 should be there. So 2 1 is also there. If this was not there, then this won't be a symmetric relation. Since this is there, then then this is satisfied for this ordered pairs. 2 2 is also there. If 3 4 is there, then check if 4 3 is there. 4 3 is there. So again, this is satisfied. Since these are equal, then that property is automatically satisfied. So it is symmetric. Then next, symmetric property is satisfied. Did you get it? Did you understand? Symmetric property. If AB is there, just check if BA is there. That's all in symmetric property. AB ഉണ്ടോ എന്ന് ചെക്ക് ചെയ്യുക. AB ഉണ്ടെങ്കിൽ അതിനകത്ത് BA യും ഉണ്ടായിരിക്കണം. അതുണ്ടോ എന്ന് ചെക്ക് ചെയ്യുക. എല്ലാ ഓർഡേർഡ് പേഴ്സണും അതിലെല്ലാം ഉണ്ടെങ്കിൽ then we say that it is symmetric. If AB is there, check if BA is there. Then third is transitive property. Now what is transitive property? Now I will take one more. So what is transitive property? I think I have to take it one second. In this, let us see if transitive property is satisfied. Check if transitive A is related to B and B is related to C. So here the B is 1. So check if there is another 1 here. So 1 is here. B is related to C. Then check if 1 2 is present. Yes, 1 2 is the set itself, so it is present. Then 2 2 is there. Then check if another ordered pair 2 1. If 2 is related to 2 and 2 is related to 1, then 2 is related to 1. Yes, this is also there. Then 3 3. 3 is related to 3. Then you next check if there are ordered pair starting with 3. 3 is related to 2. Then you have to check whether 3 2 is there. Yes, 3 2 is also there. Okay. Then next you take 2 3. If 2 3 is there, again you have 3 2s there. Check if 2 2 is there. 2 2 is there. Then 1 3 is there, 3 1 is there. Okay, so check if 1 1 is there. 1 1 is also there. So if this property, that is if A is related to B and B is related to C, then just check if A is related to C. This is present. And it is present for all these cases. So we can say that it is transitive. Okay. AB und BC undengi, then just check if AC is there. That is transitive property. So if all these three properties are satisfied, then we call it as equivalence relation. Okay. Is it clear? Any doubts? Any doubts? ഡൗട്ട് ഉണ്ടോ ഇക്വലൻസ് റിലേഷൻ എന്താണെന്നുള്ളത്? 3 പ്രോപ്പർട്ടി ഒരു സെറ്റ് തന്നു കഴിഞ്ഞാൽ ആ സെറ്റിൽ ഒരു സെറ്റും അതിന്റെ റിലേഷനും തന്നു കഴിഞ്ഞാൽ ആ റിലേഷനകത്ത് 3 പ്രോപ്പർട്ടീസും സാറ്റിസ്ഫൈഡ് ആണോ എന്ന് നമ്മൾ ഓരോ ഓർഡർഡ് പെയർ എടുത്ത് വെരിഫൈ ചെയ്യാം. അതിൽ ഏതെങ്കിലും ഒരു പ്രോപ്പർട്ടി മിസ്സിംഗ് ആണെങ്കിൽ അത് ഈക്വലൻസ് റിലേഷൻ അല്ല. 3 പ്രോപ്പർട്ടിയും സാറ്റിസ്ഫൈഡ് ആണെങ്കിൽ അത് ഈക്വലൻസ് റിലേഷൻ ആണ്. ഓക്കെ, ക്ലിയർ ആയോ? ഡൗട്ട് ഉണ്ടോ? See, you have to work out more examples. നിങ്ങൾ കുറേ എക്സാമ്പിൾസ് ചെയ്യുമ്പോഴായിരിക്കും നിങ്ങൾക്ക് ഓരോന്നിലും ഡൗട്ട് വരുന്നത്. അപ്പം ഇതിങ്ങനെ ഒന്നോ രണ്ടോ എക്സാമ്പിൾസ് വെച്ച് മാത്രം ചെയ്ത് തീർക്കാൻ പറ്റില്ല. ഓക്കെ, സോ ഐ വിൽ ബി ഗിവിംഗ് യു സം ട്യൂട്ടോറിയൽ ക്വസ്റ്റ്യൻസ് ഇൻ ദി ഈവനിങ്. അത് നിങ്ങൾ വർക്ക്ഔട്ട് ചെയ്തിട്ട് മൺഡേ വെക്കണം. ഓക്കെ, then see, if two elements A and B, if they are related by an equivalence relation, then we say that A is equivalent to B, and it is denoted by this simple A is equivalent to B. Then another example of equivalence relation is the equality of numbers, equal to relation. Equality of numbers or the equal to relation is also an equivalence relation. Equal to relation. Equal to relation on a set of real numbers is equivalent relation, because the equal to relation satisfies reflexive, symmetric and transitive property. That is, if A is equal to A, so it is satisfied for any positive integer A. So reflexive property is satisfied. Then if A is equal to B, then B is equal to A also, since it is equal to. If AB exists, then BA will exist. Since it is equal to property, then we say that if A is equal to B, then B is equal to A. So symmetric property is satisfied. Then next is transitive property. If A is equal to B and B is equal to C, then A is equal to C. Okay, so transitive property is also satisfied. So since reflexive, symmetric and transitive property is satisfied, then we say that this equality relation on a set of positive integers or real numbers is equivalent relation. Equality is an equivalent relation. Also similarity triangles, similarity of triangles are also equivalent relations. These are two examples of equivalent relations. So I uploaded these notes. You have to write it down in your notebook. If you are not able to write it down now, you have to write it down later. Till the portions I cover, you have to write it down in your notebook. Now write down this question and find out the answer. Write down the next question. Let A. Are you writing it down? Write the next question. Let A is equal to 1, 2 and R is equal to 1, 1, 2, 2, 1, 2, 2, 1. Okay, write down this question. Show that R is an equivalent relation. Did you write down the question? Let A is equal to 1, 2 and R is equal to 1, 1, 2, 2, 1, 2, 2, 1. Check if R is an equivalent relation. By looking at the relation itself, you can easily say whether it is equivalent or not. Is it an equivalence relation? Just check. Do you know how to do it? Did you understand how to do it? Any doubts? Doubt unda? 56, around 53 students are there and I get response from only 5 or 6 students. ആ ക്വസ്റ്റ്യൻ എഴുതിയെടുക്കാം ഒന്നും കൂടെ ഡിസ്പ്ലേ ചെയ്യണോ ക്വസ്റ്റ്യൻ let A is equal to 1 2 and R is equal to 1 1 2 2 1 2 2 1 show that R is an equivalent relation ആകർഷ് എഴുതിയ ക്വസ്റ്റ്യൻ ഓക്കെ എഴുതിയെടുത്തിട്ട് അത് ചെക്ക് ചെയ്യാം ചെക്ക് ചെയ്യാൻ അറിയാമോ എങ്ങനെയാണെന്ന് അറിയാമോ ചെക്ക് ചെയ്യുന്നത് ഇക്വലൻസ് ആണോ എന്ന് എങ്ങനെയാണ് ചെക്ക് ചെയ്യുന്നത് ഓക്കെ ആദ്യം അത് റിഫ്ലെക്സീവ് ആണോ എന്ന് ചെക്ക് ചെയ്യും ആ റിലേഷനകത്ത് ഓർഡർ പേഴ്സ് നോക്കി റിഫ്ലെക്സീവ് ആണോ എന്ന് നോക്കും പിന്നെ സിമെട്രിക് ആണോ എന്ന് നോക്കും അത് കഴിഞ്ഞ് ട്രാൻസിറ്റീവ് ആണോ എന്ന് നോക്കും ഇത് മൂന്നും സാറ്റിസ്ഫൈഡ് ആണെങ്കിൽ ഇറ്റ് ഈസ് ആൻ ഇക്വലൻസ് റിലേഷൻ എഴുതുക ഓക്കെ സോ we'll continue in the next class. Say your attendance. Number 1.
Present.
Number 2.
ഉറങ്ങിപ്പോയാ 1.
Present.
2.
Next 2.
2 present.
3.
4. Absent.
6. 8.
9. Okay.
10.
11. 11, 12 present. Okay, next
13.
14
15.
present. 15 present. 16. Absent. 17. Okay. 18.
Present, ma'am.
Next.
19. 20.
Next. Okay. Next.
22.
Next. 23 absent. 24 absent. 25.
25.
Okay, 25 present. Next. 26 absent. 26 on the. Okay, 26, then 27.
27.
Okay. 28.
28.
29 രാവിലെ എവിടെ പോയി? 29 present, then
30. 31.
okay.
31.
Okay.
32.
Okay.
33.
Okay. Okay.
4.
Okay. 35 present, then next.
36.
Okay. 37 absent.
38.
Okay. 39 present. 40.
41.
40 absent. 41 present. 42 absent. 43.
42.
Okay, 42 present, 43 present, then 44. Okay, okay,
45. 46.
okay. 47, absent. 48,
48.
okay. 49, okay.
49.
50, 50 absent,
51.
okay.
52. 53.
54 absent, 55 present, okay. 54,
56,
55,
57.
56,
okay,
57.
okay. 58 present, okay,
59.
okay. 60 absent,
61.
okay,
62.
okay,
63.
okay. So absent is number 4, 16, 23, 24, 40, 47, 50, 54, 60. Okay, thank you. Fifty. Sarang, okay. 50%, okay. Thank you.